Let us go, cabbages. Now, my favorite part of this review is when the 20 million of you come and ask me, Mr. Myers, can I use the letters more than once? A term may be used more than once or not at all. But I didn't use all the letters, Mr. Myers. I know, because a term may be used more than once or not at all. So, who would like to go? I'll take the first two from any volunteers. Yes, Jezreel. F and E are absolutely correct. I will take the next two from any other volunteer. Wyatt, hit me. A and H are absolutely correct. I will take the next three from any other volunteer. Wyatt, it appears you're the only person, you and Jazreet, that did their work. Go. C, absolutely correct. G, absolutely correct. And what was your 7? I did not hear you. B, as in bum? Yes, well done. Give yourself a mark out of 7. Is there anybody that needs any of those explained to them? In other words, you put a different letter than what is written there. Anyone? Going once. Going twice. Going thrice. All right. 7 out of 7 for everybody so far. Next one. Again, a term may be used more than once or not at all. Who would like to do 8 and 9? Jazreet. I'm sorry, what was your 8? D as in doornail and E as in elephant. Yes, absolutely correct. My favorite animal, elephants. Did you know they bury their dead? Only other animal in the world that does it. And you know what else they do? They take their youth to play in the graveyard so they can visit with their grandparents. True story. Messed up? What?
It's weird.
Really?
Yeah.
You walked around a city anywhere where humans live, there's vast tracts of land for dead bodies to live in. And people go back and visit all the time, even though we have a homeless problem. In Vancouver, where a lot costs $1 million, there's like whole blocks of cemeteries. Yes. And you think it's weird that elephants bury their dead?
No, it's weird that they go and play with their... Yeah.
We go back and visit graves all the time.
Play with them.
Well, of course not, because it's buried. All right. 10 and 11. Don't all put your hands up at once. It's not like it's the end of the unit and everybody should be getting these or nothing. It does make it hard to choose. No one? Carlin! A, absolutely correct, because it is the Radicand, which is directly in your notes. What about 11? That's a tricky one. F, yeah, look at you. Whoever said that, I don't even know who it was. Nice. And then 12, 13, 14. I heard someone say C, that is absolutely correct. And then I heard someone say D, which is also absolutely correct. B for 13. 14. 14, root, symbol, and an index. Root, symbol, index, and Radicand. And you're saying it is B? I would accept B, but I would rather have F. But I'm willing to give the mark for B. If you have B or F. I'm in a very good mood today. I'm in a very good mood today. That's awesome. Shoot. Okay. Oh, so that was another 7 marks available to you. Now, when you are filling in blanks, there is obviously more than one word that will answer these questions, yes? But they are all synonyms of each other. A great many of you, I would like to think, would write the proper word, add the exponents. But of course, I have had kids say plus the exponents, which is my personal favorite. I have also had kids say sum the exponents, which is okay. At least it's a math word. Anything like that. I have had kids say addition the exponents. Not really an English phrase, but whatever. Anything to do with adding the exponents when you are multiplying powers that have the same base, and you get the mark there. Power to a power. Anyone? Multiply. Would anyone like to volunteer the word that I see most often instead of the actual proper word? Times, of course. You times the exponents. Any non-zero base raised to the exponent of what is equal to 1? 0. And there's 3 marks available to you there for a total on that page of 17 by my count. Give yourself a mark out of 17. Then it makes it real easy at the end to tell me what you got. Instead of going 1, 2, 3, 4, 5, 6, 7, you just have to add up a couple of numbers. Sorry, you just got to plus up a couple of numbers. Number 4, I don't know why it disappeared. The result of raising a fraction to a negative exponent is the same as the result of raising the blank of the fraction to a positive exponent. There are a million words here that you guys could write. The proper word is, of course, reciprocal. But I've seen the flip. I've seen people write the opposite, which isn't actually true because the opposite of 1/2 is not 2. The opposite of 1/2 is negative 1/2. But if you write opposite, I believe that you know what you mean. Flip, opposite, reciprocal. I've heard many things there. You know what you mean. If you wrote down that x over y to the negative 2 is the same as y over x to the positive 2, something that means that, you can have your mark there. I trust you. You know why? Because I got a grinchy heart. Okay? Okay. Number 5, 15 to the 1/2. What's that the same as? Square root of 15. If you wrote the 2 there, that's fine. I wouldn't ever take a mark off for that, but I would like to remind you, of course, that we don't usually write the 2 there. Number 6. 4 to what power? 5. All you had to do is go 4 times 4 on your calculator until you got up to 1024, and then count how many times you pushed 4. The edge length of a cube with a volume. What do you got to do to 343 to find the length of the side? Need an eraser, buddy?
No, I need an extra pen.
Well, why didn't you just say so? There you go. What do you got to do with a cube to find the length of the side? Cube root. So some of you will have wrote this because you don't know how to find a cube root on your calculator. But that, of course, shouldn't have mattered because you could have also done it the old-fashioned way by hand, and you would have found out that it was 7. If you wrote cube root of 343 and didn't bother simplifying it, you may have a half a mark. This one's tricky. What do I put for x to get to here? -3, because you had to flip the fraction, right? Because 4 cubed is 64, but if the 4 was in the numerator spot, then 64 would also have to be in the numerator spot. That's a really tricky one. I'm going to give everyone a chance to ask about that one more time before I move on. Does everybody understand what a negative exponent does to a fraction? Flips it or reciprocates it, right? Because negative exponents cannot exist because they make no sense. Everybody's good when I tell you 7 to the negative 2. Everybody remembers, oh, that's 1 over 7 squared. But the one that everybody forgets is if I give you a negative in the denominator, it's got to come up. Everyone forgets that one. Hint, hint. Everyone forgets that one. So I like to make sure it's examined on the test. Hint, hint. Do you all understand what I am saying? Hint, hint. Okay, just checking. That mixed radical, when written as an entire radical, is the cube root of what? What? If there's 1 3 out there and it was a 4th root, how many 3's were under there? 4 of them. 3 to the 4th is 81. There was already a 5 under there. 81 times 5 is 405. Ah! And this one, this is also one that causes trouble. This radical, when expressed as a power. So, if this is the radicand, what does it become when I make it a power? So if you could do number 5, everybody that got number 5 right should be getting this right. The radicand became what as a power? Carlin? The base. So that must mean this radicand becomes the base here, yes? Excellent. The denominator became the index. So this index becomes what? The denominator. And what number goes above it? 1. Now, if you left it that way, you may have, oh heck, take the full mark. Go ahead. But, of course, what you should have done is made it m to the 2/3 over n. Because you would have multiplied that in. Right? So if you got to here, you can have the full mark. If you got to here, you know what? You take yourselves a bonus mark. So you could get 51 out of 50 on this if you did it all right. That's how good a mood I'm in. There's another 7 marks there. All right. Prime factorization. So we broke it down. How did we break it down? What did you start with? Because it ends in 2, because it ends in 4, what could you have started with? What? What could you start with? You could try 4. 4 goes into that twice, and that's going to leave 2401. So 4 and 2401, right? Okay. Now 2401, what you going to do there? You went up to 7 and got 343, and then you could have stopped there if you have all your squares memorized, right? Because that's 2 times 2, that's 7 times 7. So 9604 is 2 squared times 7 cubed. Yeah? I lie. 7 to the 4th. That's 7 cubed. Sorry. There we go. And that's worth 2 marks. A. Write and evaluate an expression for the area of each pair of squares. If the sides are 5.1, then what's the area of A? 5.1 squared, which is 25 point blah. And B is 3.5 squared. And that's going to be like 11. I don't know what they are because I don't have my calculator out. But if you wrote 5.1 squared and you went to your calculator, you're going to have gotten it right. I don't know what the answers are. 2 marks there. C, 4.3 squared, 9.3 squared. Now, total area of each pair of squares. Right, so you had to add it. So that's going to be like 36. And that's going to be like 16 and 85, like 102 if you added it up. If you didn't read the question right and add it up, I'm giving you full marks anyway because it's the squaring that's important. So that's going to be around 17, and that's going to be around 85. Making that page, I think, oh no, there's one more here. This one's going to be out of 3. Now, once again, is there a right way or a wrong way to do this question? No. There's a right or a wrong answer, and there's a right or wrong numbers to write depending on what you do, yes? But is there a right order in which you need to do things? No. So you're going to need to simplify in 3 spaces here, aren't you? At some point, you're going to need to simplify this blue part, right? And at some point, you're going to need to simplify this green part, right? And at some point, you're going to need to deal with that yellow squared. And then at the end, you're going to need to simplify all of it, right? So how you go about doing this is your business. Okay? I personally start with this because it's the busiest spot, right? And simplify means to make things simple, yeah? So I start with the busiest spot there. What could I do with everything that's in blue there? What could I do with the A's? Combine them to get A to the 3. What would I do with the B's? Add them to get B to the 4th. What would I do with the C's? Add them to get C to the what? 6. Over. But all that is squared, yes? Now, Mr. Myers always says, if you start one step, it's not a bad idea to finish it all the way through. So we started on the numerator. Do you want to finish on the numerator? We're right there anyway. What would you do with that 2? Multiply it in to get A to the 6, B to the 8, and C to the 12. Top's clean, yeah? Let's look at the denominator. What do I do with that 3? Multiply it in. So I can skip this middle step, can't I? I can just bring this right out to here, yeah? What is B? 6. And what is C? 15. Now what? Simplify again. It's going to be subtraction of exponents because it's division of exponents, right? So, does A get touched? Why? No other A's. Does B get touched? Yes, why? Because there's other B's. Now, if you are having trouble with this, once again, if you know what's going on, you can figure it out, because that means there's 8 B's, right? Right? 8 of them. And on the bottom, how many are there? 1, 2, 3, 4, 5, 6. What happens to the first 6? They cancel, leaving you with 2. In the numerator, the shortcut, 8 minus 6 is positive 2, so the 2 can stay in the numerator. C, 12 minus 15. It's negative 3. Negative 3s aren't allowed, so it would have to go down to the denominator. Now, the reason I show you this is to remind you that if I had 12 C's up top, and I'm only going to draw 4, and 6 C's on the bottom, when you cancel those 4, those 2 are still down there. So when I cancel all 12 of these, that cancels 12 of these, doesn't it? So I can take away 12, leaving me with 3 that are already on the bottom. Okay? Some kids like to do that cancel thing instead of subtraction. Whatever. Whatever works for you. I am not the arbiter of what goes on in your head. Yes? It's whatever you need to make it work. So you decide how much of that you did right to get your 3 marks. Obviously, if you have the correct answer, you did everything correctly, because you couldn't get that answer without doing it right. Making that page out of 2, 4, 6, 9, and 7, making that page out of 16, with the possibility of 1 bonus mark. Last page. How do I put those in order from greatest to least, which means the biggest numbers first? What should I do? Notice I did not give you any rules. You could do anything you wanted. How do you know what order to put those in? What can you do? Jordan, you can punch them all into a calculator, can't you? You can do 2 times the cube root of 5, square root 30, 4 times the square root of 4, and 3 times the square root of 6. Would that have been allowed? Absolutely correct. Is there another thing you could have done? You could have converted them all into what? So they're all entire radicals, yes? So this would have been the cube root of 40, right? This was already the square root of 30. This would have been the root of 64. And this would have been the root of 54, right? Then you could have just put them in order. Now, why is this tricky? What did I do to make this a little bit trickier on you? I made one of them a cube root, yes? So you had to think a little. The cube root of 40 is what? Cube root of 27 is 3, right? And the cube root of 64 is 4, right? 40's in the middle, but closer to 27, yeah? So this is something right around 3.5-ish maybe, right? Which would mean it's about the same as the square root of 10, right? Because the square root of 9 is 3. So that's about the square root of 10. So I had root 10, root 30, root 64, root 54. What's the biggest of those? Root 64, which was 4 root 4. Then what's next? 3 root 6. Then what's next? Root of 30, which is root 30. And then what's last? 2 cube root 5. And you're going to get 2 marks for that, because even if you punched it all into your calculator, you still had to know quite a bit of stuff, like how to do cube roots and things. Express each radical as a mixed radical. 1 mark each, because you only had to do one thing. What's 45? 9 and 5. What comes out? 3. What stayed under there? 5 for 1 mark. Oh, hey, cube root of 40. Hey, we were just talking about that, weren't we? What's cube root of 40? That's 8 times 5, right? Why did I use 8? Because it's got a cube root. What is it? 2. So out comes the 2. Cube root. What I leave under there? 5. Let's pretend you don't know, you don't remember the cube roots like you were supposed to memorize. Then you break it down. 2 times 20. 2 times 10. 2 times 5. There's your group of 3. So out comes the 2. If you still don't know how to do that, I'd recommend writing that down right now if you haven't written it down the first 30 times I did it. And I would recommend watching the video of the first 30 times I did it, plus this one. 243, what do you break that down into? 3 and 81. Why can I stop there? 81's got a square root. What is it? 9. What did I leave under there? 3. 1 mark each. Express each radical as a power. So, the radicand becomes what? The radicand becomes the base. Thank you, Carlin. The index becomes the denominator, and the power becomes the numerator for 1 mark. Ooh, this one's tricky McTrickleton. What's the base? X to the 4 over y to the 3. What's the exponent? What's the index here when it's not written? 2. So, what's this? 1 over 2. Could you leave it like that? Is that a power? Am I perfectly happy if you leave it like that? Yes. Could you go 1 step further for a bonus mark? What would it be? X squared over to the 3 halves. That gets you another shot at a bonus mark. Those are 1 mark each because you're only doing 1 step. This one, whoo, doggy. That's a tricky one, isn't it? Cube root of all that. Well, isn't that the same as the cubed root of 64 times the cube root of n to the 4th? What's the cube root of 64? 4. What's the cube root of n to the 4th? Cube root means I'm looking for a group of how much? Group of 3. Do I have a group of 3 there? So out comes an n, and what did I leave under there? 1n. Am I at a power yet? Not quite, am I? I've got 4n. What do I do with that to make it a power? The radicand becomes what? The base. The index becomes what? The denominator. The power becomes what? Numerator. If you got to there, do you get the full mark? Sure. Can you get a bonus mark? Why? Aren't they the same base? So what would you do with the exponents? Add them. What's the exponent with this first n? 1 or 3 over 3, right? What's 3 over 3 plus 1 over 3? 4n to the 4/3. Am I allowed brackets there? No, I'm not. Because the 4/3 only applies to the n because root of 64 was 4. And that'll get you another bonus mark. This question was to see if you understand what's going on. There's 8 people in the game, right? The question says, how many rolls are expected? Right? So how many people do you expect to be out of the game after the first roll? You got a 50-50 chance, right? So how many people do you expect to be out of the game? 4. Because half of them are going to roll even, half of them are going to roll odds, yes? Okay. So after round 1, we all roll, and there's 8 of us that roll in round 1, yes? How many are left to roll in round 2? 4. Then what? How many are left in round 3? Round 3. 2. And after round 3, who's the winner? There's one guy left. Does he or she need to roll? No. So how many rounds did we need? 3. And it's cube rooting, right? It's breaking down 8 into its prime factors. 2 and 4, 2 and 2, 1, 2, 3 rounds. I'm only making it 1 mark because it's a tricky question. But it's one of those questions that shows the difference between who is memorizing how to do stuff and who is understanding what we're doing. Making that page out of 2, 3, 4, 5, 6, 7, 8, 9 with the possibility of extra bonus marks. And the last question. I'm in a little bit of bind here because as you can see in mine, that plus sign printed. But it's not there in yours, is it? So I don't really know what to do here, although it's pretty obvious because the person wrote -1. So it had to be -0.25 plus -0.75. So, is she okay up here? Is -1/4 -0.25. Is that okay? Yeah. Excellent. Now, is she okay here? What should she be doing there? Subtracting. So it should be -0.25 minus -0.25, shouldn't it? So, is she right to have put that plus there, minus minus? Is she right to make that addition? -3 minus -4. Is she right to make that addition? Yes. Is she right to leave that negative? Yes or no? No. There's her mistake. So this is not okay. So the error she made, you subtract exponents. And negative something minus a negative is the same as negative plus. And the correct solution right there is -0.25 plus 0.75, which is what? 0.5. So the answer was 3 to the 0.5, which is the same as 3 to the half, which is the same as square root of 3. But I will give full marks for either of those. So you get 1 for the mistake, and I'm going to give 2 for the correct solution, making that last page out of 3. Making the whole thing out of 12, 28, and 17 is 38, and 7 is 45. Plus the possibility of up to 3 bonus marks. So you could get 48 out of 45 if you did everything right. When are you going to tell me what you got on this?
On the test.
On the test. When is your test? Approximately Tuesday, assuming nothing goes wrong between now and Tuesday. Now, you guys got 14 minutes left, and I said that for the rest of today, I wanted pages 122 to 124 finished. If you get them done now, you got no homework. If you don't get them done now, you got homework. Do you have to draw the pictures? No, I don't care. You can just tell me the answer. 122 to 124. And in part of my new strategy, I am ending every video actually writing down what you were supposed to do. I've already written this once. So I cannot get any of this, I didn't know what you're supposed to do, Mr. Myers.